Ever wondered how much fuel it takes to send a rocket to the moon? The Artemis II rocket carries millions of kilograms of fuel. Interestingly, when that fuel burns, the main exhaust is just water vapor. Here's a question. If rocket fuel turns into water and creates almost no pollution, why don't airplanes use it to stop polluting the skies? Stick around, because the answer shows why space travel is so incredibly hard. Every kilogram you send into space needs 20 to 30 kilograms of fuel just to get there. And here's the crazy part. Most of that fuel isn't lifting the astronauts, it's lifting the fuel itself. To lift 1 kilogram of payload, you need fuel. Then extra fuel to lift that fuel. And more fuel to lift that extra fuel. That's why rockets are mostly fuel. The crew takes up surprisingly little space. The SLS rocket is enormous. Its orange core holds about 2 million liters of liquid hydrogen and over 700,000 liters of liquid oxygen, enough to fill nearly 3 Olympic-sized swimming pools. 2 giant boosters on the sides carry nearly 1.4 million kilograms of solid fuel, a rubber-like material that burns incredibly fast to create massive thrust at liftoff. The rocket burns fuel at a mind-blowing rate, about 6,000 kilograms per second. In just the first 8 minutes, almost all the fuel is gone. Compare that to a passenger jet, which might carry 100,000 kilograms of fuel for a whole long flight. This rocket burns far more than that, in minutes. Once in space, the spacecraft mostly coasts. Engines are only needed for translunar injection and minor course corrections. On the way back, only tiny bursts are used for steering. Now, here's the fascinating part. When liquid hydrogen and oxygen burn, the exhaust is mostly water vapor, one of the cleanest rocket exhausts possible. So why don't planes use hydrogen instead of jet fuel? Hydrogen has huge energy for its weight, but it takes up too much space, must be stored extremely cold, and is expensive to produce, more than it's worth. Regular jet fuel is easier to store, safer, and fits neatly in wings. That's why planes still use it. Rockets can afford huge tanks because escaping gravity demands extreme power. So next time you see a rocket launch, remember this. Millions of kilograms of fuel lifting more fuel, just so a small crew can leave Earth and come back safely. And the main engines? They leave behind nothing but water. Space travel is wild, and the physics behind it is even wilder. Thanks for watching Brain Melt Lab. If your brain is still recovering, take a moment. Subscribe. And join us next time, when reality gets even weirder.